Another feature we have in spanning tree protocol is called the BPDU filter. Now, there's two ways of enabling that feature. What it does essentially, and the operation depends on how we enable that. We can enable this on per port basis, or we can enable this globally. If we enable this globally, very often it is combined with the global portfast statement. So what does BPDU filter do really? What it does, it filters BPDU on the port, but depending on how we enable that, it depends on how we enable that in terms of the either per port basis or globally, it works differently. So the intention of this BPDU filter is to make sure that somebody maybe does not connect mistakenly a switch where the PCs or routers or non-switch devices should be connected. But before I see the details of how BPDU filter works, let's step back and talk about portfast and the way we can enable that. Portfast feature can be enabled per port basis or globally. So I did per port basis, but I never showed anyone how to do this globally. So let's just jump back here, and the behavior is pretty much the same. So at this point, if I do conf-t interface, actually let's go do show spanning tree interface E12, and if I see this is an edge port. The edge port becomes when I enable either per port basis spanning tree, which I did not here. It's not on the per port basis. I enabled portfast globally. What's the command? Do show run include portfast. So when this command is enabled globally, spanning tree portfast default. It's the same like I enable this on every single port. So what the system does with this command is checking all access ports, not trunks, and if they never received BPDU, the port becomes an edge port and skips the listen and learning states. In fact, I can display that if I add do show spanning tree interface 1.2 portfast. It'll show me that the portfast is enabled. Now, irrespective if I do this per port basis or globally, there's an important thing we must know. When the port does receive BPDU frame, which in my case did not, do show spanning tree interface 1.2 detail, it never received BPDU frame, it becomes a portfast. When it does receive the BPDU frame, irrespective whether it is per port basis portfast statement or global portfast statement, it loses that portfast feature edge capability and it goes listen and learning. The reason I mention that because with the global statement for this portfast, I can add an extra global statement which reads spanning tree portfast BPDU filter default. So now I have two statements in a global config mode. I have added the BPDU filter to the portfast. So what it reads basically, if you see the portfast enabled, and we enable them on all access ports that never receive BPDUs, just enable also BPDU filter on those, right? So what does it do if it's enabled globally? It basically, what it does, in fact, I'll show you interface E12 from scratch. I'm gonna do shut the port down. This is gonna clear any counters on the port. I can also clear spanning tree counters, this command, same thing. When I enable the port, before I do that, do show span interface E12 maybe detail, nothing there because spanning tree is not enabled, is disabled because the port is down, no shut. What is going to happen? The switch is going to send initially, upon coming up, 11 BPDU frames checking if there's a PC, if what is connected actually to the port, because there's a PC1 connected which is not sending BPDU back. After 11th check, it'll stop doing this. So let's see that. It sent already 9 BPDUs, and if I do this again, 11, and it won't go any further. I can actually filter this, maybe include BPDU. That's it, 11. BPDUs are sent every 2 seconds, but we're no longer sending anything. And the reason we stopped, because we checked, is that if there was a switch connected here. There wasn't, because we didn't receive any BPDU back, right? So it stopped sending BPDUs. So that's how it behaves when it is actually connected to a device that is not sending BPDU at all. So BPDU filter assigned globally, like this, is going to filter BPDU going out. It checks first by sending 11 frames if a switch is connected. If not, it stops sending BPDUs. It prevents anyone from capturing packets and learning about our root bridge MAC address, about its priority and stuff like that. But what happens if the BPDU is at any point in time sent back? So let's just say somebody connects a switch to it right now. I'm going to emulate that by using a switching on my PC. So I'll do this. This is a router, so I can do this easily by doing bridge VLAN 1 protocol IEEE and enabling this on E02 port of this device. So if I start sending with this command, I'll start sending BPDUs now. When that happens at any point in time, so if this switch was using BPDU filter globally assigned with PortFast, what it's going to do is basically is going to start acting as a regular port, and it does the election, listen, learn, and stuff like that. In fact, let's just jump back here and check this. Maybe by this time we already received something. There we go. So we sent already 12 and received 12, and so on and so forth. We'll receive 15. So normal election is going to happen. Now let's stop that. So I am going to do no. I'll stop sending BPDUs. It doesn't matter at this point. It's just doing regular stuff. Shut the port down to clear the statistics on the ports. And now let's just remove the command, global command. I'll say no, spanning tree PortFast default, BPDU filter default, this one. And what if I enable BPDU filter on the per port basis? That's behavior is different. This will prevent from maybe miscabling. So if I assume that there should not be any switch connected to this port E12, if I enable BPDU filter on this port, which is per port basis assignment, it filters BPDU out and in, and it will ignore any BPDUs coming in. So it won't go listen, it won't go learn, it won't be behaving like a normal port connecting to the switch. So the command on the per port basis is spanning tree BPDU filter enable. That is the command on the per port basis. So this is the command on a per port basis. When I bring the port back up and start sending BPDUs on towards that port, it doesn't matter. At this point, if it's per port basis, it will ignore any BPDU coming in. It will not send any BPDU out at all. So there won't be any election happening on the port. Do show, do I have this command? There we go. So my port now, even though this guy is sending BPDUs, do show span 1, I'm sending now 16 packets, now 18 packets, BPDU packets, and so on and so forth. The port of a switch ignores them, and there is no election happening on the port. That prevents the port from maybe a mistake switch connection to the port. There's a better way of protecting your network against rogue switches connected to access layer, and this is going to be in my next video.